Why, hello there, lovely ones. So we are going to continue changing from standard form, a parabola or quadratic function from standard form, into the turning point form. And there are two different formulas that you've been exposed to. The one is with the minus p and the other one is with the p. They're pretty much exactly the same, but the difference comes in how you define the turning point then. Okay, but let's go back to this problem. We've got y is equals to 9x squared minus 2x minus 10. The whole point of completing the square is that I'm wanting to get to a point where I've got x plus or minus something squared. Let's make it plus and see what happens. There may be something happening over here, and there may be something happening over there, and at this point, I don't really care about it. I am focused on this over here. So if we take a look at what we've got, that 10 at the moment is pretty pointless. I ignore it because it just makes things difficult and I put it on the outside. That way it makes it easier for me to see that I'm only going to work with these. My problem though is that I've got 9x squared minus 2x and I don't want that 9. That 9 is horrible. So I'm going to take out 9 as a factor. It does leave me with something that's quite ugly, but not unmanageable. So now I've got 2 over 9x minus 10. And the reason why it's not unmanageable is because I know whatever the coefficient of x is, in order to get that value over there, I just have to divide it by 2. So let's do that. I've got negative 2 over 9, and I'm going to divide it by 2, which means I'm going to have negative 1 over 9. So let's take that away, and I'm going to put negative 1 over 9. So that's the brackets that I'm hoping for, and therefore, at least better English, those are the brackets that I'm hoping for. I've got x minus 1 over 9 squared. In order for that to work though, I need to do some magic in those brackets. Everything else is going to stay exactly the same. That minus 10 hangs around out there. I've got x squared minus 2 over 9x. And now how I know what I need to do is I quickly multiply this out. So let's just move it up a little. Now I'm going to write out the long thing. I hope you are able to just square a binomial without doing this, but let's just prove it. I've got x squared minus 1 over 9x. So I'm doing FOIL minus 1 over 9x, and then it's going to be plus 1 over 81. So that leaves me with x squared minus 2 over 9x plus 1 over 81. So in order for this to become that bracket, I need 1 over 81 to be added. So I go back to this over here, and I add 1 over 81. But my big problem at this point is if I've added 1 over 81, I have changed the value of what's happening in this equation. So I have to undo the adding of 1 over 81. And the way I do that is I do the opposite. So I added 1 over 81, and now I subtract 1 over 81. Okay. So let's try and make this look a little bit more pretty. I'm going to highlight the fact that I just want to work with those now because that's what's going to take me to those brackets that I have been hoping for the whole time. The whole point of completing the square is to get to the point where I have x minus 1 over 9 squared. I've completed the square. It's great. There it was, and there it is. I still have that pesky 1 over 81 being subtracted and that minus 10, but that's okay because I can now multiply things out and make it look pretty. So let's just get rid of some mess around there and let's move this over. I'm going to do that by multiplying that 9 into the brackets. So there are two terms that are there. It becomes 9x minus 1 over 9 squared minus, 1 over 81 times by 9 is going to give me 1 over 9. So minus 1 over 9 minus 10. And then that, I'm just going to write it as an improper fraction. So there we go. And minus 10 and 1 over 9. That means that our turning point is going to be a horrible looking one at this coordinate. So just to zoom out, the whole point of completing the square is to go from these 3 over here to getting to x minus something squared. Everything else that happens, everything else we do is just getting us to this point over here. That's all we want.